Good morning, everyone. Trust we're having a good day. Apologies for not being able to drop this yesterday as earlier scheduled. I had some technical challenges that sort of forced this to be dropped today. But I'm excited to be here. This is going to be a really exciting journey as we go on together. My name is Daniel. For those that know me very well. For those that are new to this space, I'm a software engineer and I will be the one driving this channel for a while. Yeah, welcome to Code with Prof. McDan. We're starting this journey together. It's 2023. Um, in terms of some of the things that we will be focusing on, very largely, we'll be looking at about six key areas. We tend to take in-depth tutorials, in-depth, sessions together on core concepts of backend development, distributed systems, all the way to databases, frameworks, technologies, and all. We also intend to, we will be looking at, best practices and techniques. Together, we'll take a project-based learning approach. We'll build certain things together based off of a number of the theoretical concept we must have explored. There will be live coding sessions from time to time where we would be able to just come together, take a very key problem and just walk through the solution together. There will be QA, some sort of community engagement where I also intend to bring on board some key people within the industry to actually come and talk to us about some of the learnings within their experiences over time, as well as once in a while we'll also talk about industry insight. What are the things that are trending? A few years ago, it's a particular sort of framework that everybody was used to, but now things are changing, and I believe things will continue to change, knowing that change is the only thing that is constant. Like I said, thank you very much. Welcome to this channel. So today we will be taking a brief introduction into backend engineering. What exactly is it? A touch on web architecture, which is probably the focus of today's talk, to then be able to look at what exactly are we going to be dealing with. So, introduction to backend engineering. Sure. For those that are meeting me for the first time, my name is Daniel. A whole lot of people call me Prof. McDan. So in case you hear people saying Prof, they're probably referring to the same person. I'm a software engineer with almost 15 years experience developing solutions across multiple domains, from healthcare to finance to telecommunication, and all that. My focus, one of the things that make me wake up very early in the morning and stay excited, is distributed systems. I'm very passionate and excited about distributed systems. I love it. In terms of languages that I've worked with in the past, and up until I probably do a whole lot more of Python right now, everything Python all the way. But of course, I work with JavaScript, TypeScript, C Sharp, quite some languages here and there. I love machine learning as well almost as much as I love web development. I'm a big fan of Django. Fast API seems to be taking over a whole lot of stuff these days, but Django is, one of the primary frameworks that I essentially work with. Currently, I work at MTN as a senior technical lead. I'm available on LinkedIn. You can follow each other. As I will also be engaging using that channel on Twitter. I go by Daniel Ali 9291, and on Instagram, I maintain Prof. McDan. So let's get to it. What are we looking at today? Three things. For me, motivation, web architecture and the building blocks. One of the things that I've always talked about is the fact that a lot of us tend to look at, you know, jack of all trade. We just want to learn everything, back end, front end, all the middle ends, and all of that. Sometimes it makes sense to start out, like a pyramid, and then as you traverse to the top of that pyramid, you begin to narrow. You become like a master of a particular domain. Yes, it makes sense to start out very wide. Of course, we all do. Starting out as a full stack developer, building HTML, CSS, JavaScript, jQuery, all of those things a few years ago. And then you begin to, as you grow older in your career, we begin to gravitate towards a particular niche area. So some people just take databases, and truth is, some people even just take, sharding as, with basic things. They become really, really, really good at not just the entirety of database. Some people will just tell you that, oh, I'm only focusing on transactions, and you can literally write a PhD thesis on new ways, new things that are being done, just taking a particular database, say Postgres, for instance, caching, and all of that. So, like I said, we intend to focus on everything software engineering at the end of the day. Like I said, the intention today is to look at the very beginning of the entire journey, which is web architecture. What is it? What does it? What are we talking about, right? When we talk about web architecture, of course, we have multiple tiers. There are the single tier, which is the one tier architecture, which is in which cases you have everything just bundled together. Is that bad in itself? No, it's not. There are use cases where you probably still want to do that. There are instances where, for instance, you're building a desktop application, for instance, where you probably still want to uh, have everything sit together on a single machine. And when we talk about tier, we're usually looking at the physical separation of components, servers, for instance. So, for instance, both the UI, the backend, and the DB, I remember those days would, sort of be bundled together as a single installer that you can share with people. Of course, it comes with a whole lot of disadvantage, but I know that even up until today, there are still tons and tons of games that still behave this way, where you download everything into the user's PC, and then you can always move on to only just ask for updates, from time to time. Secondly, we have the two-tier, architecture, where it's usually divided into like a client, like a client and server kind of thing. And what that means is that the client, which is essentially the UI, built with HTML, CSS, whatever that is. Whereas the business logic and while the server itself is essentially the database, so you have the entire things built together. So the client holds all of the business logic, the business rule. Look at it like the back end and the front end are sitting together on a single server, and you have database sitting separately on another server, right? Is that a bad thing in itself? Maybe not. There are specific use cases. Maybe not all the time that you want to build something like this, but a lot of the times, sometimes we build games that are based within the browser, for instance. Games that we can play within the browser. It makes sense to have this so that the day you don't have network, for instance, everything can still stay, and then it makes sense. And when there's network, you can always just sync your data. Sometimes you want to build a to-do list. This is probably not a solution you are looking at, having too many. You can have that logic sit directly on the client's browser, on the client's machine, whereas the database is sitting somewhere else. It could be in the cloud, it could be within an on-prem environment. The other one, which is usually the most popular one of the most popular ones, is the three-tier solution, is the three-tier architecture, where the UI, the backend, which is usually the business logic, and the databases are essentially sitting on like three different machines. In this particular instance, you have you know what that helps to do, it builds resilience. So for instance, when one goes down, the other one doesn't necessarily go down. You can scale the different tiers individually. You can apply all manners of stuff to that, which is usually the most popular these days. You can have a database sitting in Azure, for instance, where you have a VM, maybe an AWS EC2 instance that where the backend code is sitting. The front end itself could be a React application deployed, for instance, on Netlify, and these are like that's already a three-tier solution. However, the third one, or the last one rather, which is the fourth one, is usually then the conversation around end-tier solution. And these days, these are becoming more popular, and I'll talk about that in a moment. But then, as we go on, I think it's important to mention that there is a subtle difference between layers and tiers, right? Like I mentioned, tiers represent this physical separation of the different components. So I can have the database server sitting in Lagos. The backend server is probably sitting on a different location in South Africa. and the front end is sitting on Netlify. Maybe that the server that is powering that is sitting somewhere in the US. Total separation of concerns and all of that. But then there is the concept of layers, which is more of a conceptual logical organization of code. And I've seen people talk a whole lot about these. Also, they also refer to this as architecture, maybe code architecture, for instance, not necessarily the way your entire project or the infrastructure is structured, but more around how do you define, for instance, some languages come with some frameworks, for instance, like Django. They already have a preferred way of doing things. So you have your models, you have your serializers, you have your views, you have, your signals, your tasks. All of those things are sort of just arranged already by default in a way that it makes sense. When you pick some other languages like Node.js, where you literally have the flexibility of defining things the way you want, that's so you sort of need to come up with a logical, and we will be taking a look at some of these things in this series where we'll be able to really look at what are some of the best practices when it comes to, organization of codes, taking maybe two or three different technology stacks as case studies. Tiers, on the other hand, like I mentioned, represent some sort of separation of concern. And let's get into it. Let's go one step in. Like I said, this is an introductory video. We just want to lay the foundation for when the actual work is then going to be coming on board. Now, a user come to a particular site. The guy wants to this user intends to do something, with your solution. He or she makes a request, sign in, for instance. In order for him to sign in to maybe YouTube, for instance, he would obviously need to open a particular web page. That web page is sitting, which is where the front end is, the all of the user interaction on the front end. Through a request response model, you talk to the back end talks to the server. This server might have a whole lot of things connected. For instance, there's a file system, there's a database, there's a caching layer, a whole lot of things might be going on under the hood. It doesn't matter what that is. It could be a SQL, NoSQL database, a SQL database, or a NoSQL database. Whatever is going on, there's a whole lot of interaction, but basically the front end communicate with the back end through some sort of defined communication approach, request, some request sort of approach. Our focus in this particular tutorial series is really on this backend layer, how things are structured. I mentioned earlier that, for instance, within the NTR application, it's possible that you have multiple things, and I'll talk about it when I'm talking about building blocks. In my head, I've always categorized the building block for a well-architected software solution. There are 16 major building blocks, 16 major ones. And we all need, you need to understand each of these building block as it makes sense along the entire value chain. But basically, within an entire application, you have your application servers, you have your caching, for instance, you have your cache, you have your message brokers, we have the queues, which could be distributed queues. We have a distributed search server, for instance, in a station where you probably need to use a Lucene or an Elasticsearch kind of stuff. You have several components that are handling, massive amount of data because within the same solution, you're probably powering a lot of, same solution. You're collecting data that is being used for transactions. You're collecting data that is being used for analysis. So you have the data science team feeding into that data. There are a lot of data pipeline that are sort of streaming data back and forth to be able to make things work. And at the very top of that, we also have several heterogeneous tech components that powers your different microservices. It's possible that your authentication system, for instance, is built with Node. The customer management service, for instance, is built with Java. So all these can come together within an entire application. It doesn't matter. And this is the focus as we go on. Like I mentioned, it gives you two major abilities, single responsibility for each of these different components, and it's an extreme separation of concern. Oh God, what is this? Somebody just looked at this and said, "Oh, what exactly is going on here?" But it's exactly the same thing I've explained earlier. I was just looking through and I saw this on the Storyblocks Engineering Medium page where I decided to say, "Oh, I'm just going to share this." These are different components. For instance, the user interact with our solution primarily from the user's browser. And by user's browser in this case, I'm also assuming that this could also loosely refer to a mobile phone, for instance, a CLI. There are multiple ways in which a user can interact with that solution. But all that matters is at the end of the day, you have your web app servers, which is essentially powering a whole lot of. It could be, it could be distributed in nations. So you have a load balancer. The data that is powering those logic is sitting within a database to make efficiency, to make room for efficiency and improve performance. We throw in a caching service so that you don't need to hit the database every other time. Within the same time, it's possible that this is an event-driven architecture, which I'll talk about in a moment. We also could have like a job queue that powers some sort of job workers and job servers that handles, background tasks, asynchronous jobs or asynchronous events, things that can happen without necessarily, especially when you build in some loose, some sort of eventual consistency, into what we do, especially where there's like an eventual consistency requirement where things can happen 5 minutes later while certain things can happen almost immediately. You have external services that you're connecting to. We have full text search, for instance. I have an email server, like I said, at the same time, we have data firehouses, that submit data or move data into a data warehouse or a data lake where the machine learning team or the data science team can pick that same data and sort of essentially just work with it. Um, this is a very high level of what is possible. But then, what are we talking about? Let's look at architecture. There are different forms of architecture that we can look at. One is what we call the client-server architecture. I've talked about that very briefly, indirectly. The client-server architecture assumes that we have, list of clients. In this case, these clients could be applications that are built with React, with a mobile app, with Angular, with Vue, vanilla HTML, CSS, JavaScript, or even jQuery, in case you're still using jQuery, where we have all of this happening. So all of these applications, all these sit on the client side. They pass through, some sort of using a request response. And this is what we might, and I'll be talking about that when I'm talking about communication in the next lecture, where a server makes a request. I want to log in, right? I collect the user's data, username, password, I submit, and then you pass that within a request body together with all the other requests, header and all of that. You submit to the server processes that particular request and returns a particular response, to you. That's those are a lot of things that happen, essentially on the client side. However, on the server side, for instance, there are a whole lot of things that happen. One of them being, what really goes on within the application servers. So these are the servers that are responsible for um, processing your request. All the routing, all the APIs that you've written, they sit there. We have web servers. After you must have deployed your application server, after you must have deployed your solution on, say, Linux OS, for instance, there is need for some sort of a layer that is responsible for exposing that traffic, to the outside world. That's where the web servers come in. Some of the most popular web servers include Nginx, for instance. There's Apache, which these are some of the two most popular. There are quite a number of other web servers that we could take a look at. Or also there is the proxy servers, which essentially are like these are servers that sort of sit in the middle there. And Nginx, for instance, some of these web servers behave also as proxy servers, where it could be either forward proxy or a reverse proxy kind of thing. There are mail servers, file servers, database servers. I mentioned earlier that when you're working within an event-driven architecture, for instance, you want to have a whole lot of batch job servers, things that are handling a lot of background tasks so that it doesn't, it reduces the load it reduces the load that is being placed on your application server. And then these things can happen and you can scale the batch job servers independently. This is an example, for instance, of what a real life essentially looks like. Yeah, so you have like I mentioned earlier, I mentioned that we have the client server architecture, but then there is the event-driven architecture where you have multiple, it could be mobile apps, CRM, sensors, cameras, whatever it is that are producing events. In this case, IO processes, right? And within in a non-blocking form, you decide that this should go through some queues and then go into like your workers, for instance, where each of these tasks can be picked up individually by different components. work done, processed, and then moved into a consumer. So, which is why we then have the entire consumer, producer, consumer kind of architecture. One of the projects I intend that we will be able to build out here um, will leverage this particular architecture extensively, and will most likely either use RabbitMQ or Kafka, to power this interaction. Another very interesting or very popular architecture that we talk about, and a lot of us already know it, is the peer-to-peer architecture. Now, this is slightly different, and it's different in the sense that you have like so each of the peers, each computer, for instance, behave as a node within that pair, and you don't have a central server like what we have within the client server architecture, where one particular server will be responsible for coordinating everything that is going on. But within the peer-to-peer or P2P architecture, um, they all have so they all behave as what we call seeders and leechers. So what that means is that for every new node or new computer or new servers that join, they are any of the servers can be responsible for seeding data into that new server and then bringing it up to date. But all of them they have some sort of equal right, within that architecture. So one person cannot just say, "Oh, I'm shutting down the entire system and I'm deleting the entire system." And that's where things like blockchain, for instance, come into play. Torrent, for instance, we've used it multiple times in the past, for instance, as students. Um, you know, now there's one other architecture that we talk about, but probably not going to talk a whole lot about it right now, is the federated architecture, which is really an extension of the decentralized architecture. One of the things that I think I saw very lately was around how Thread, for instance, is planning to adopt. I mean, I think one of the developers in Facebook, that's Thread, spoke about how Thread is planning to adopt the decentralized social network protocol. It may not happen immediately, but what that means, essentially is that I really wish Twitter and all of them can do that, such that when I make a post on Twitter, I can actually go to thread and actually have a feel of, still be able to connect with the people I connect with on Twitter seamlessly because they all sit within the same pool. But there's been a number of, solutions that have used such things, that are leveraging that Mastodon, Mine, Diaspora, etc. A number of other things that I want, like I mentioned today, is just going to be let's talk through what we really want to talk about, and then we're going to be taking each of these one after the other in the coming days and in the coming weeks. As we then go, we do a lot of deep dive, write codes, and all of that. But let's talk about it at a very high level. Some other architectural pattern that people talk about a whole lot and that is being used extensively within distributed systems. One, webhook, for instance. Yeah. And a very good example for some of us that have used webhook is a situation where if I connect to a payment gateway, for instance, and payment is made within your solution. You don't now it takes you can't determine exactly at what point that process is going to complete on the third party that you're connecting to. So the best approach is to submit that request, and rather than doing a polling, using a polling approach every other minute to actually keep checking, is this what's the status of this particular transaction that I've made, which is going to be an inefficient approach. One, it puts a lot of pressure on the server that you're on whatever server you're getting that you're actually pulling from. It also takes away a lot of processing time from you. That time that you're using to actually check if that transaction status has changed, you can use that time to do something else. The best approach is to prepare an API on your own end and give it to that provider and say, whenever this transaction changes, call this API. This API will update the status of this particular transaction on my end. That's what some call it webhooks, some call it callbacks, and all of that. There's also the shared nothing architecture, which is quite interesting. What that means essentially is that for the different, when we're building distributed systems or we're having all of these conversations, we want to build in a way that there is pure separation of concerns, where data is not being shared, infrastructure is not being shared, especially such that when one service goes down, all the services can still continue to run, in a very good way. Hexagonal architecture is also another architecture that we talk about a whole lot, where we use the concept of port adapters and domain to bring everything, to create an independent, loosely coupled solution. The entire solution sits in the middle within domain, and then you use port and adapters to then connect it to the UI, and all of that is quite interesting. I know it's also there's also the clean architecture that we talked about. Now, that's at a very high level. Well, because this is an introductory video, I also don't want it to be uh, to take too much time. But over the next few weeks, this is where we're coming back to. I mentioned earlier that I have these 16 components. I think I just love it this way, having 16 different components that we need to look at and be comfortable working with when we then begin to think about building a robust, scalable, distributed backend system that can scale and support, tons of millions of users. One of them, of course, is the domain name service, which we all know. The DNS, we have the load balancers, for instance. Load balancers are largely responsible for helping you distribute your traffic. When I get there, we'll talk about some of the most popular algorithms for routing this traffic, especially in a situation where I have this solution that I have that is probably supporting some artists, let's say. And then overnight, I went from 200 users to 2 million users overnight. Of course, the system needs to scale. I can decide to then say, instead of having this deployment instead of scaling out that particular server vertically, where I increase the RAM, increase the CPU memory, and all of that, I can decide to just take that same server and just replicate it multiple times, so that when requests are coming in, I can use some sort of algorithms to decide which of the servers pick it up. That way, I'm distributing that traffic over a number of servers. Of course, this is where load balancers then come in, whether I'm then just doing round robin to make that selection. I'm using some more efficient algorithms to deal with it. Databases is also another thing, another big component that we will be talking about within this series. From SQL, NoSQL, we will talk about transactions. We'll talk about some, key major low-level concept within databases that allows us to be able to understand how it works better. The B minus tree, for instance, the B plus tree, the AVL tree. We'll talk about the while, which is right ahead log. We'll see how to go beyond just writing SQL queries to these databases and just doing insert and update and delete and find and all of that, to then be able to see, how do I scale, in a single night, when my application becomes overly popular and everything begins to change. What happens? How do I handle that? How do I also ensure that systems don't break? How do I deal how do I deal with data integrity, for instance? How do I ensure that I don't lose data in the case of in a situation where traffic suddenly goes up, or where there is a crash, for instance? Key value stores, those are also very another key concept that we will be looking at. Caches, for instance, whether it is Redis, and all of that, monitoring, sequencers, CDN, queues and pub subs. Those are things that we intend to look at extensively. Rate limiters, where do they come in? How do we use them? And sometimes we might even go ahead and design our own rate limiters. Distributed search, for instance, how do we make the best of that? How does it work? What are the algorithms that that sort of power that? Counters, for instance, are also another very important, and a whole lot of solutions these days. It's important to understand how they work. Task schedulers, blob storage, logging, for instance, which is a major one. I think that works almost hand in hand with monitoring, just ensuring that, so that the day there is crisis, we need to have the confidence as developers, not just in writing code, so that we will also be able to sleep better at night. It's important to be able to put the right observability strategy in place to ensure that things don't go out of hand. Now, what does next step look like? Like I said earlier, one of the first things we're going to be dealing with, and which is going to lead almost directly to our first project, is the communication that happens between systems. So there is the TCP, there is the UDP, there is the QUID, there is a whole lot. You'll be surprised that sometimes just picking the right technology stack, picking the right communication approach, picking the right protocol to communicate with can reduce even the code you need to write. Sometimes I found myself, for instance, in the past, there was a time I did a project. I think it was a stream. It was like a streamer. Used the Raspberry Pi at the time to actually build out a small solution that sort of streams video over the internet. And trust me, I did that project over. I used the REST. You won't believe it. It was a long time ago. I used a REST API to manage that process. It was a mess. Whereas there are a number of other more efficient protocol communication protocols that have been designed for those kind of use cases that I could have used. Imagine wanting to build a chat system, and I don't know, there's something called WebSocket. For instance, I want to detect, for instance, if users within that chat system are online or offline, how to detect presence, for instance. I can do that using REST API, of course. I can decide to keep making a whole lot of calls, just checking, is this guy online, is he offline? But there are protocols that have been designed to help manage, presence. So there are just a number of things. So which this is what we're going to. The next lecture is going to be power packed. It's going to be highly technical. So unlike this first video that is a whole lot of introduction and just looking at everything from the beginning. But I look forward to this exciting journey. This is not a journey we intend to finish in a month or in 2 weeks or in no, it's going to be a long one together. But the whole purpose here is that we want this channel to be a place where you can come to when you have that issue you are trying to deal with and be able to quickly get that repository of knowledge that helps you grow faster. Like I said, I'll be happy to take specific questions about the things I've talked about in the comment section. And if you want us to make the next session a live session, that would be good. You can just holler, just mention that in the comment section, and we can figure a way out to actually just pick a particular time when we can have that live session so that people can ask questions and we can all learn together. Thank you very much, and have a wonderful week ahead. Bye bye.